Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is periodic properties and variation of properties. Children, what are periodic properties? Obviously, the properties which appear at regular interval of time in the periodic table is known as periodic properties, and the phenomenon is known as periodicity in properties of elements. Children, there are totally 6 periodic properties. The first one is atomic radius, second one ionization potential, then electron affinity, electronegativity, and finally metallic and what children? Non-metallic nature. Now, in this chapter, what we are going to do? Children, we are going to learn the definition of all these periodic properties, and these properties are going to depend upon what factors and how these periodic properties are going to vary what across the period and down the group. Okay children, straight away let us proceed with the first periodic property, that is atomic radius. Children, before we proceed with the atomic radius, we all know that atom contains nucleus. Inside the nucleus we have a protons which is having a positive charge, and also neutrons which doesn't have any charge, and electrons revolve around the nucleus in a circular path known as orbit, and the charge of the electron is negative. Right children? Children, if I write like this is the nucleus whose charge is positive due to the presence of what children? Protons. And we have a circular path, right? These are nothing but energy levels, or orbits, or shells. This is the place the electron revolves. Now children, observe here, right? I have put one cross here. This indicates electrons. Now common sense says that I'm just trying to make you understand the definition of what children? Atomic radius. Don't try to identify which element is this, right? Some atom. Now common sense says that the distance between the center of the nucleus and the outermost shell containing electrons is known as atomic radius. I repeat children, what is atomic radius? The distance between the center of the nucleus and the outermost shell containing electrons is known as atomic radius. Now children, this atomic radius is going to depend upon what factors? Children, if you want to have nicely, what are the different factors that will depend upon? Obviously, aroma, taste, or somebody should treat you free of cost. There are many factors. In the same way, atomic radius is going to depend upon what factors? Mainly 2 factors. That is, it depends upon 2 factors. One is nuclear charge, and next one is what children? Number of shells. These are the 2 factors on which our dash depends upon. Our atomic radius is going to depend upon. Children, first of all, we'll come to nuclear charge. What is nuclear charge? Very simple. Nuclear charge, nucleus. Charge possessed by the nucleus. What is the charge of the nucleus? Obviously, the charge of the nucleus is positive. Why the charge of the nucleus is positive? Because it has got a dash in it, pros or protons. Now, nuclear charge is nothing but the charge possessed by the nucleus due to the presence of what children? Protons. Now children, how nuclear charge and atomic radius is related? Now, observe here very carefully. I would like to take some 2 or 3 examples just to make you understand the relationship between nuclear charge and atomic radius. Don't try to identify the atom. This is one atom. Inside the nucleus we have 3 protons, and this is one more atom. Inside the nucleus we have 4 protons, okay, and this is one more atom. Inside the nucleus we have 5 protons, right? Now obviously this positive charge proton will always look for what, children? Definitely they'll look for what? A species which is having a negative charge. Now see, this is the electron that is present in the outermost shell. Now children, use your brain and tell me, 3 people are trying to pull the electron that is present in the outermost shell, 4 people are trying to pull the electron present in the outermost shell, and 5 people are trying to pull the electron that is present in the outermost shell. That is, what I am trying to say is that the nuclear charge is continuously what, children? Increasing. Now, in which case the electron will come closer to the nucleus. Obviously, common sense says that more people are pulling here, the electrons will come closer here, right? Now, common sense says that, see, it will come very close, little close, very little close. Now, what is the conclusion you can draw from this one? As the nuclear charge increases, the electrons in the outermost shell are pulled with greater force. Then what will happen to the size of the atom? Children, 1 minute. If I hold my hand like this, it is called as a nucleus. If I hold like this, then outermost shell containing electrons. See, once again, as the nuclear charge increases, the electrons in the outermost shell are pulled with what, children? Greater force. Then the size of the atom is going to what, children? Decreases, right? I repeat, as the nuclear charge increases, that is, as the protons increases, the electrons in the outermost shell are pulled with greater force, then the size of the atom is going to what, children? Decreases. So children, conclusion from this one is, this atom will be the what, children? Smallest, and this atom will be the what, children? Biggest, right, children? Children, I have one small question actually. What is the relationship between nuclear charge and atomic radius if it is like this? Now common sense says that, can I write something like this? What is the meaning of this one? As the nuclear charge increases, the electrons in the outermost shell are pulled with greater force, then the atomic radius is going to what, children? Decrease. Children, what do you call this relationship as? I hope it is called as something like this. What is this one? Inverse relationship. As the nuclear charge increases, the atomic radius is going to decreases. I hope you understood this one. Right, children? Now, what is the next factor that it is going to, like, what is the next factor on which the atomic radius depends upon? Number of shells. Now, children, this is very simple actually. Right? Atom 1, right? I'm sorry. Atom 1. And as you know that this is nucleus, children. Atom 2. And this is atom 3, right? It is something like this. Now children, this atom has got how many shells? 2 shells. This atom has got how many shells? 3 shells. This atom has got how many shells? 4 shells. Now children, use your brain and tell me, out of this, this and this, which is the biggest atom? Obviously the one which is having how many shells, children? 4 shells. So this is the biggest. So which is the smallest shell? The one with how many shells? 2 shells. So this is the smallest and this is the largest. Now what is the relationship between atomic radius and number of shells? It is very simple, children. It is a direct relationship. As the number of shells increases, what also increases? Atomic radius also increases. So these are the 2 factors which will affect the atomic radius. Now children, we will see how this atomic radius is going to vary this way, that is across the period. Now children, for that we will consider one of the the elements present in one of the period. Now for example, if I take the elements of period 2, which are the elements of period 2, children? It is lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, and what, children? Neon. Now children, Electronic configuration of these elements, it is 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7, and what children? 2 8. Children, one observation. What this 2 and 1 indicates? That is, 2 electrons are there present in K shell and 1 electron is present in what children? L shell, like that. 2 in K and 2 in what? L, something like that. Now common sense says that children, lithium has got how many shells? 2 shells. Beryllium, 2 shells. Boron, 2 shells. So all the elements have got 2 shells. Then the size of all the atoms should be same, no? According to the number of shells concept. No, it is not same actually. See, according to the number of shells concept, all the atoms have got same number of shells, but the number of shells is not only the factor that is going to decide the size of an atom. There is one more factor. What is that factor, children? Nuclear charge. Now, use your brain and tell me what is happening to the nuclear charge across the period. According to me, the nuclear charge is continuously what, children? Increasing. That is, 2 electrons in K shell and 1 electron in L shell. That is 2 plus 1 is what, sir? It has got how many electrons? 3 electrons. Children, we all know that in any atom, the number of protons and the number of electrons will be what? Same. That is, the number of positive and negative charges will be same. That's why an atom is said to be an electrically what, children? Neutral. Now, 3 electrons are there means obviously it should be having what? 3 what, children? Protons. Right? So 4 electrons means 4 protons. 5 electrons means 5 protons. 6 electrons means 6 protons. Right? Now, common sense says that, as I told you before also, nuclear charge is nothing but the charge possessed by the nucleus due to the presence of dash in it, protons. Now, when you go across the period, what is happening to the number of protons are nothing but nuclear charge. Obviously 3, 4, 5, 6. See, 4 is more, 5 is more when compared to 4, 6 is more when compared to 5. That is, when you go across the period, the nuclear charge is continuously what, children? Increases. Now, as the nuclear charge increases, previously only we have learnt, as the nuclear charge increases, the electrons in the outermost shell are pulled with what, children? Great force. Then the size of the atom is going to what, children? Decrease. Right? Now, out of all these elements, which element is having a maximum nuclear charge? I hope it is neon. Which element is having a least nuclear charge? That is lithium, which has got how many protons? 3. Neon has got how many protons? 10 protons. Now, conclusion from this one is, in this period, the smallest atom will be which one, children? Which one, children? Neon, and the biggest one will be lithium. Now, children, we'll see. Children, one thing what I would like to say, what I would like to tell is that, see, I am writing the values just to make you understand the concept, right? No need to remember these values, right? Kindly observe this, children. Observe this one. Now, all these are given in Armstrong units. 1 Armstrong is equal to 10 raised power of minus 10 meters, right? So, no need to worry about that one. So, it is 1.55, 1.12 Armstrong, so 0.88, 0.77, 0.70, 0.60, 66, 64 and 1.12. Okay, right, let me cross check again. Right, okay, something like this. Children, just observe the values. 1.55 to 1.12, you call it as what, children? Decrease. 1.12 to 0.88, decrease. This to this, decrease. 0.77 to 0.70, decrease, decrease, decrease. What is this? Just now I told that the neon is the one that is having a maximum nuclear charge. So more nuclear charge means its size should be small. So what is this? The size of the neon is bigger than the size of what? Fluorine. But actually it should have been smaller. So it is something like this. See, observe here. I am just showing you the variation of the atomic radius of period 2 elements. Okay, observe here. Lithium. Which one is that? Smaller than lithium. Beryllium. Boron, still smaller. Carbon. Nitrogen. Oxygen. Fluorine, still smaller. Actually, neon should have been still smaller than fluorine, but it is bigger. I repeat, children. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. What is this? Some problem in the values? No, children, no problem in the values, right? Now, the question is, the size of the neon should have been dash than the size of fluorine. That is, it should have been smaller. Why the size of neon is bigger? This we will learn in the next class. Okay, children? So, across the period, the atomic radius is going to what, children? Decreases because of increase in nuclear charge, and the number of shells does not have any role to play because all the atom have got same number of shells. So this is the conclusion. Okay, children, I hope you have understood this one. And this question, neon, why it is bigger, this we'll learn in the next video. Thank you, children. Namaste, everybody.